I'm the awesome tutor, and today we're going to be looking at the life cycle of stars. And this requires a lot of memorization. There is no understanding whatsoever, it's all memorization, and you need to know this because it does come up in your exams. So, Stage 1, Nebulae. And these are just gas clouds containing dust and hydrogen. And these early stars are called protostars. And what happens to them is gravity pulls matter towards the center, and these start forming stars. So they become more dense, so when pressure increases and they become hotter. And this is what we call the Goldilocks conditions, which allows nuclear fusion to occur in stars. But this occurs in the main sequence. So stage 2, the main sequence, this is where nuclear fusion occurs. Nuclear fusion occurs in the main sequence where small nuclei like hydrogen fuse to form larger nuclei like helium. And this main sequence is for a long time. It's 90% of the star's lifespan. Now, the bigger they are, the harder they fall. So the bigger the star, the shorter its lifespan. And so high mass stars have a shorter lifespan, and low mass stars have a longer lifespan. So stage 3. Now this is where things start to get different for low mass stars and for high mass stars. A low mass star is a star that's kind of similar to the size of our sun, and high mass star is a star that's bigger than our sun, much bigger. So for low mass star, a red giant is formed. For a high mass star, a red supergiant is formed. And both these are formed because in the main sequence we run out of hydrogen for fusion. But fusion still occurs. Now the main sequence star massively expands, either into a red giant for low mass stars or a red supergiant for high mass stars. And in this sequence, you can form heavier elements by fusion, but not higher than iron. Then we have stage 4. For a low mass star, it's a planetary nebula. For a high mass star, it's a supernova. And both of these happen because the red giant or the red supergiant, in the case of the high mass star, become unstable. And so the outer layers are ejected. And the thing about the supernova is there's enough heat and energy to form elements heavier than iron. And so the main thing is they explode. The red giant or the red supergiant explode. Now stage 5 is where no fusion occurs. There's no more fusion. Fusion was in the main sequence or in the red giant or red supergiant sequence. So for the low mass star, a white dwarf is formed, which happens because the core contracts into a white dwarf, so basically it shrinks. And then the white dwarf cools into a black dwarf, but this is hypothetical because the universe is not long enough, it's not old enough to know this, because there are no black dwarfs at this current moment because our universe is not old enough, our universe is too young. Now for high mass stars, it either forms a black hole or a neutron star after the supernova. So a neutron star is when the core collapses into a dense mass of neutrons, so it's made up of neutrons. But sometimes instead, the star will collapse, the star's core will collapse into extremely dense matter, which is a black hole. So it's much more dense than a neutron star, and this black hole is usually formed with bigger stars, and has such a strong gravitational pull that light cannot even escape it. And yeah, that's all you need to know for the life cycle of stars. This has been the Awesome Tutor. Bye!